Um, so like I said, there'll be an alternate assignment and it won't be a penalizing assignment. It'll be a normal size homework assignment as an alternative. So if you just don't want to do it, you're adults, you can choose that, but you will be incentivized to do it by getting to skip another assignment. All right. But it's also for your own good anyway. So it's not like I'm just forcing you to go and do busy work. But these hackathons are kind of what you make of it. And we'll try to encourage team leads. Not that we had a problem, I think last year, where we had a team lead just switch technologies to something he's working on at work. And that didn't go very well for that team. But they got to pick something that's kind of in your wheelhouse so you can at least follow what they're working on, even if you're, a little bit behind the 8 ball. All right. So last time we talked. Oh, go ahead. Bad, good, bad,
No,
complaint,
I was
bribe. All right. All right. So last time we talked about static versus non-static, specifically focusing on when you're defining the methods versus when you're calling the methods. So when you're defining methods, you make a method owned by the class by putting the static keyword in front of it, right? If you don't want it to be owned by the class, instead you want it to be owned by instances of the class, you just don't put the word static in front of it. Okay. Refrain from putting the word static in front of it. When you are calling these methods, if the method was defined with the keyword static in front of it, you must call that method using the name of the class in which that method was defined. If the method was defined without the keyword static in front of it, you call that method using an instance of the class in which that method was defined, not the class name itself. Okay, so these two slides, super, super, super important. They unlock especially the second one. When calling these, they unlock the entire documentation for you. And this doesn't just stand for Java. This will go for C# and Swift and all sorts of other languages. Go ahead. Well, it's not necessarily a benefit or not a benefit. It depends on, remember we were talking last time, kind of like you have you could think of it like a toaster. If something only exists once and you want it to kind of work as a factory and you throw data at it and it does its job and then spits it back out at you, that would probably be a static method if that's what it's doing. Now, if instead the method belonged to a class where each individual instance of that class kind of had uniqueness, for instance, strings, the length method is a non-static method because every single string potentially has a different length. So that method needs to internally work on data that instance knows about, rather than you feeding it external data for it to do its factory job. Kind of makes sense? It's not that one is better or worse than the other. It's they define whether really under the hood, this factory needs to be built one time and that method exists one time and you just feed it the data it needs to work on, or does it need to duplicate that method for every single instance of that class you make? Because each of those methods operate on the internal data of that instance rather than some external data you feed it. Okay. It's not a better or worse thing. It's just what's the right tool for the job. All right. So, but the question you just asked really has to do with this slide, making the decision yourself when you're writing these things. And we'll see some of that as we start writing our dungeon crawler today, when we make those decisions. Should something be static or not static, or public, private, protected, similar type things? We'll introduce those, because that when you're inventing stuff, now it's on you to decide what's the right thing to do, as opposed to when working with this slide, when we're trying to figure out, hey, how do I call a method that's already been defined? Sure, maybe it's a method I wrote, maybe it's a method he wrote, probably not. Okay, maybe it's a method he wrote. But more than likely, we were looking at this documentation, it's a method that somebody at Sun Microsystems or Oracle wrote 20 years ago, and you need to call it today. right? And it doesn't really matter what mentality they went through for making it static versus non-static. Hopefully it follows something along the lines of what I just explained. But at the end of the day, you have to be able to call it. And that static keyword gives you all the information you need to know, do I call it with the name of the class or do I call it with an instance of the class? All right, so it lets you read the documentation. Yeah, if you remember last time, do I still have the documentation open? Do I have too many tabs? Java. Here we go. Yeah, so here's the, for instance, this, what do I have, the string class? Here, let me get to java.lang here. So if I look at the character class here, we scroll down to the method summary. All these methods, notice they have static out in front of them. This one does not. This one is an instance method, but all these other ones, they have static in front of it. So with this one, we call it, we say character.char count, because that's the name of this class, as opposed to the string class. When we look at that, we, like I used that example with length, each string kind of needs to know about its own length. So having that knowledge of the internal value that that string holds. So if I scroll down here, we go to that length method. Here's the length method. Notice static is not over here. It still has the return type of an int, right? Because when you ask what's the length, you expect it to give you a number back, but it's not static. So that says I need to create a string first, string s equals hello. And then I can say s.length to get the length of s, or s2.length to get the length of a different string variable. Okay, I don't call it by saying string.length because it doesn't have static in front of it. Make sense? Yeah. Because sometimes you're going to write your own code. This is the stuff that the Sun Microsystems gave you, right? So I'm telling you that the likely mentality they went through is that factory versus, example that I used. That's probably how they were thinking, because more than likely they chose kind of the right tool for the job, but there might be some questionable things in the documentation there, but you don't have any control over that. You just have to call it the right way, right? But when you're writing your own code, like we're about to write a whole bunch of methods and stuff for our dungeon crawler, well, now it's on us. We have to decide, well, do I put static in front? Do I not put static in front? And it's not a coin flip. There's a mentality behind it, and we'll look at it as an example when we start writing them. All right, go ahead.
I just want to understand what you mean by like it only like you give I mean, you can use it multiple times, but it's like,
so here's the character class. The character class operates on char primitive types. Chars are built into the language, so they hold a value, and that's all they can do. Now, it would be reasonable for us to say, it would be nice if Java gave us a tool for turning a char to an uppercase version of itself. That would be nice, right? To be able to convert a character to uppercase. So we look at this class called character, which exists solely to operate on primitive types, char primitive types, because they can't do things to themselves. They're primitive types. So if I roll down and I'm browsing this and I'm seeing in the method summary, oh, is there a 2 uppercase dealy flippy thing in here? Let's see, it's know your ABCs. Yeah, so here's a 2 uppercase. I have to give it a char, and it's static. He exists one time. This is like our toaster. This is a single machine that's sitting there called 2 uppercase. And I have to feed it the character that I want it to convert to uppercase for me, because it doesn't have any internal knowledge. Like strings have an internal knowledge. If I create a string s equals hello and a string s2 is equal to world, s knows about hello and all sorts of crap about that. S2 knows about world and all sorts of crap about that. So a majority of those string methods will be instance methods. They won't have static in front of it, and they likely aren't going to necessarily be taking very many parameters, because at the very least, that instance of the string already knows about hello or already knows about world.
That input, that parameter, is that a static variable?
The input is not. So if I were to call this, let's just look at it as an example. So here's my main, let me just gut this. Okay, so if I want to do a system dot, well, here, let me just create a char. I'll say char C is equal to a lowercase a. And I'll say system, blah, 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 blah. So I say that versus, so that's just going to print a lowercase a out, right? You can run that, it's going to give us a lowercase a. You can do it. Stop. Run. Well, in any case, trust me, this is going to print out a lowercase a because the value, this variable C holds a value and that value is a lowercase a. All right. Now, if I wanted to get the uppercase version of that value, I could say, is in the Java documentation, is there already a tool in there that knows how to convert chars to uppercase? And I happen to find the character class. And we saw that the toUpperCase method in the character class is a static method. And because it's static, how do I call it? Using the name of the class in which that method was defined. The name of this class is the character class with a capital C. So I would say character dot toUpperCase. Now, when I go into the documentation and I look at what parameters this guy takes, so right off the bat, by saying character dot toUpperCase, I know toUpperCase must be static. That's why I called it using the actual name of the class rather than an instance of the class. But because it's the name of the class, it doesn't know what data, it doesn't know what char I want to convert to uppercase. That's why this guy takes a parameter. I have to toss it something for it to convert to uppercase for me. That's kind of that toaster analogy. You put the toast in there in order for it to toast it. And then it pops out your answer. Toast, you got toast. So I would put in that variable C. And what am I asking it to do? I'm asking it to take this char C, which is actually lowercase a, and use the character dot toUpperCase factory to boil down to an uppercase a. That's what that will happen. That's what will boil down there is an uppercase a. Does that make sense? But the character class doesn't know about that value A or a value B or Z or whatever. It doesn't know that it doesn't have internal data. That's why I had to provide it an external piece of information, as opposed to if I say string S is equal to hello, I say string S2 is equal to world, and then I say system.out.println S dot toUpperCase. S is an instance of the string class. If I go into the documentation for strings, because it seems reasonable that we might want strings to have the ability to convert themselves to uppercase, right? So I go find the string class in here. I scroll down to toUpperCase. Here's the toUpperCase method right here. Notice it does not have static in front of it. That means it's an instance method. It's owned by individual copies of the string class, instances of the string class. Therefore, in order to call this method, I call it using an instance of the class. I don't say string.toUpperCase. I say s.toUpperCase or s2.toUpperCase. And because of that, notice this guy does not take any parameters. It already knows what I want to convert to uppercase. Either the internal value of S, which in my example here is hello, or the internal value of S2, which in my example is world. So I don't pass in any parameters because the documentation says I don't need anything else to work. Call me with the instance that you want to convert to uppercase, and I'll do it for you. So this is more of an apples to apples example because we have a method that effectively is doing the same kind of thing. One is operating on chars, okay, where the char primitive type can only hold a value, and the other one is operating on strings. So when I build this string, which is an object type, I can now ask it to do some stuff to itself. Whereas chars don't work that way. Since chars are primitive types, they only know how to hold values. I can't call methods using a char. But instead, I can build this factory that I can feed chars to, and it can do stuff to them. That makes some sense? So that's kind of an example of maybe the problem solving that the Sun Microsystems people went through when they were deciding, should this be static or not static for string versus characters. Strings can already hold values about themselves. All right, so let's start creating some of our classes. And you know, I think some of these things will become clearer as we're writing them, okay? So here's our dungeon crawler dealy flippy thingy. All right, so we decide a dungeon is going to be a collection of rooms, where one of those rooms is going to be the starting point. We decided a room is a collection of inhabitants as well as exits. We decided an exit is a door leading to another room given a direction, just like we had last semester. Now, this is where things become a little bit new for us. Last semester, we had a player, and you told me we never made rats. Okay, so we had a player that was just human control. We told it to go north, south, east, west, whatever, and he ran around through our little maze we created, our dungeon, right? Presumably, if we wanted to build a monster like a rat, he would have been similar, but he wouldn't be human controlled, right? We would place him in our starting room, and then if we took it the one step further, where maybe we were doing some kind of dice roll to decide whether or not he should choose to switch rooms, wander into the room to the west or something like that, it would have been completely computer controlled, not controlled by a human being. So that would be like, let's say, the differentiating factor between a player and a monster. One is the human dude, your player. The other one is completely a non-player character, NPC. But we can say, because we want to introduce inheritance here, we can say, you know what? They're both actually inhabitants. They are things that inhabit our dungeon. And so there may be some commonalities. Maybe all inhabitants have a name, for example. Okay. And then from inhabitant, we build players and we build monsters where a player behaves a certain way that's different than a monster, but they both have that commonality of having a name. All right, so we're going to write that in code in here as well. All right, so let's start off with a room. All right, so we're going to write actually, let's just start off with a dungeon. We'll just go in order here. All right. So we're going to create the name of the class must match the file. So we're going to create a file called dungeon.java. Still cooking. Let me do this. I'm a little concerned about reloading, but nailed it. All right. Are we still in my right project? Let me go to my projects. Java. How can I have two of them? Dun, 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 dun. Man, we didn't even look at which one had code in it. So good. All right. Get rid of that crap. Let's get rid of all that crap because all that stuff's dead to us, right? All right. And then I always start off with a little system.out.println, whatever. Let's see if this runs. Run that dude, and hopefully we get some kind of output. And there it is. So we have a functioning program right now. Okay, off to a good start. All right, so now we want to, remember, all programs begin and end with main. So now we want to go ahead and we want to start adding our objects into this. So we're going to add a new file. We're going to call this guy dungeon.java. I spelled that dude right. All right. All right, and this guy is going to be, I'm going to make it a public class for right now, but it can actually be a class. Give me a little leeway on explaining public yet. I'm going to show it to you once we start dealing with fields. All right, so we're going to say public class dungeon. Okay, so that's what that's a blank dungeon at this point. And why don't we go ahead and create our, actually, I'm not going to create other classes yet. Let's just roll with this. All right, so we have public class dungeon. Go back to our documentation here, what we've written. We decided, okay, a dungeon is a collection of rooms where one room is the starting point. Okay, so I really need to know about two separate things when it comes to my dungeon. I need to have a collection of rooms. All right, and we've learned about collections. What variable type are we likely going to use based on what we know right now to hold a whole bunch of a same type? An array. All right, so let's start off with an array, and maybe we'll upgrade it later. All right, because at some point I might show you array lists. The whole next course, 300, is about better versions of that. Linear linked data structures that can expand and contract at will. Okay, because we know that arrays, even though they're fast, they require contiguous memory, which is memory in a row, right? And because of that, they're really fast, but they're also memory inefficient, right? We can request a giant plot of land in real life, and if we build a little shed in the corner, we're wasting a whole lot of space that nobody else can build on. All right, kind of the same idea here. So we want to create a collection of rooms, as well as we want to keep track of a single room that is the entry point for our dungeon. All right, so we're going to go ahead and we're going to say, I want a room array. Let's call this guy the rooms. And then I want to have a room called starting room. All right, I'm going to leave it like that for right now. These are our fields. Okay, very similar to C++, except in C++ we actually C++ we didn't we had a public section and we never even used the private section, but we don't have that in Java. Instead, we do it on an individual basis. What we're going to add public, private, or protected in front of this. If we don't put anything here, which I would say never do, it technically has a security setting of package level. In C++, the equivalent of that is, anybody know? Any C++ developers in here who know what it's called if you don't put public, private, or protected in front of a variable, what the default is? Good coding trivia. Called friend. Friend. It's like a friend of the family. Okay. Something in the same directory, effectively. It's a friend of this class. Where in Java, we have this thing called a package, where we haven't defined our own package here, so we may not even in this course, but we'll see. So if you don't do one yourself, it gives you the default package, which effectively says the crap that's in the same directory. All right, so don't overthink it. It's a directory structure thingy. All right, so right now, any other class, any other code stuff that is inside the same directory as this dungeon.java has access to this stuff. We don't know if that's good or bad right now, but that might be something we care about. You know, at your house, sometimes you lock certain things up, sometimes you don't. We might want to lock some stuff down sometimes, and we'll look at that by example. All right, so now I'm going to go ahead and I'm going to have our constructor, just like in C++, constructors must have the same name as the class. All right, now, who? Oh, thank you. See, I was testing you, you got it right. Yeah, whenever I make a mistake, it's because I did it on purpose and was testing you academically. I have real low hopes for... All right, so we're going to go ahead and build a constructor for our dungeon. And initially, we're going to say, you know what? I don't have any rooms to throw in here yet. Therefore, I don't even know what my starting room is. So I'm going to go ahead and not have anything in this constructor and do nothing currently. So mostly our dungeon class right now is a waste of time. We've promised that we're going to have the ability to hold a bunch of rooms. And we've promised that we'll have the ability to remember what the first room is, the starting room. Okay. But I haven't even invented rooms yet, so I can't even start messing around with those. But at the very least, I know that my I have an array. I have a variable capable of holding an array called the rooms, but I have not given it a size yet. I haven't actually created that array. So I'm going to say this dot the rooms. Okay, tactically you could just say the rooms for the same reason as last semester when we said this with the little arrow guy, and that allowed us to specify whether we were talking about a local variable or one of the fields. But I suggested you always use this dot when you're talking about the fields, even if it wasn't necessary. It'll make you spell things wrong less often, and it's might even give you a speed boost since you're not requiring it to resolve that variable and look in 3 places before it gets up to the top. So we're going to say this dot the rooms is equal to a new room array. And just for right now, why don't we limit our dungeons to 100 rooms? For no good reason. I'm just throwing a number out there. Okay. We could even do this here. Let's connect the dots here. We can say that a dungeon, when you're building it, takes in a parameter for the maximum number of rooms. And then we'll just use whatever that parameter is to define our array of rooms to hold whatever we've dictated is the maximum number of rooms. Okay. And then as far as we know right now, the starting room is nothing. So I'll go ahead and initialize it to null. I promise you its value is already null, but just like last semester I mentioned, never rely on default values. At this point, the purpose of a constructor is to initialize an object. So I'm initializing my object. I'm creating it in its starting state, which says, okay, I have something capable of holding max rooms, number of rooms, and I have something capable of holding the starting room. I don't know what that's going to be yet, so I'm just going to set it to nothing initially. All right, that makes sense? Go ahead.
Is there like some greater reason of what's capitalized or lowercase? It just depends on.
It's more of a naming convention. Classes tend to be capitalized. It's not required, but naming conventions across all object-oriented languages, if you look at documentation and stuff, classes usually start with a capital letter. Methods usually start with a lowercase letter, but a common thing is to use something called camel case, which I've kind of done here. Max rooms for like a variable. So I've kind of spelled out what this guy means, but this follows something called camel case, where it starts off with a lowercase. So that kind of helps us differentiate where we know that guy's not a class. He's kind of in an illegal place to have a class anyways, but he's not a class. And because he's not a class, we're probably going to use this camel case thing. But again, it's a naming convention. You can make everything all caps if you want. All right. So when we build a dungeon, we'll go ahead and require them to tell us how many rooms is the maximum number of rooms for this dungeon for right now. We'll go ahead and ask the operating system using our real estate agent to give us enough memory to hold this many of these guys. We haven't invented those guys yet, but once we invent them, it's gonna have enough memory for those guys. And then we go ahead and initialize our starting room to nothing. Yeah. I don't remember. It's perfectly reasonable to do it. I don't remember. I mean, if we didn't do it, that's fine. But yeah. All right. So now if I go back out to main here, I can go ahead and I can say, okay, well, I want to go ahead and create a dungeon. Call this guy the dungeon. and he's going to be a new dungeon. And remember, we've required that dungeons take in at the time of creation the maximum number of rooms that that dungeon can have. So we'll go ahead and put 100 here. So we're building a dungeon that only knows how to hold 100 rooms. Only. All right. Now this guy can't do much right now. In fact, if I compile this right now, it's going to scream at me and say, hey, I've never heard of a room. Okay, I'm referencing rooms all over the place in here, but he's never heard of it. So let's go ahead and let's build room to kind of get that problem out of the way. And then we'll start looking at some of these things with public, private, protected. So I'm going to create a new file. We're going to call this guy room.java. All right, and this is going to be class room. Did I make the other one public? I did. So let's just stay consistent with that. I'll explain why later. Frankly, calling it just classroom is actually probably more correct, but it'll make more sense later. So let's say public classroom. What does a room have in it? Let's refer back to our starting point for documentation. Did I screw up? Did I? Oh, is it, did I misspell it in the worst way? Yeah. All right, everybody close their eyes. That was see, sometimes I make mistakes on purpose to trick you in ways that test your morality. It's a Christian worldview thing that we try to do here. And I put it on Slack too. Oh. I just tell people you wrote it, and they're like, yeah, isn't that the spinning card guy? I expected worse. All right. So let's look at our documentation thing here. So at least class is always entertaining. All right. So a room is going to be a collection of inhabitants and exits. Well, I don't have those guys yet. So for right now, let's just say a room. A room is probably also going to maybe have a name. I think from last time we named this like S118B and that kind of stuff. So why don't we say a room is also going to have a name? Okay. So we're going to ignore the inhabitant and exit part for a minute and just say it has a name. Name's probably going to be a string. Okay. We'll come back in here. So we're going to say string name. Then we're going to have our constructor room. And this guy will take in a string as a parameter. I'm going to call it name because that's what it's going to be, is the name. And this is where we actually need to use this keyword, because I need to be able to differentiate between the field name and this local variable name. So I want to set this guy equal to this guy. So I'll say this dot name is equal to name. All variables resolve to their most local definition. The most local definition for name, it's going to look locally here first before it looks up here. And it's going to say, oh, I found a variable called name right here. That must be what you're talking about right here. As opposed to on this side, I'm specifying, I want you to not look locally. I'm talking about the field that belongs to this particular instance of room. I'm referencing this dude up here. All right, just like last semester. Couple of upgrades already, though. We notice we don't need the little arrow dealy. Doesn't exist in Java. Java knows that we are talking about a pointer that points to some stuff, so it dereferences it for us. It knows what dot means to us in this particular case. Okay. Another upgrade. Notice we didn't have to include any header files, in our case here, over here in Dungeon. I'm using rooms here, but I didn't have to include anything in here. I just had to make sure I had to make sure I invented room at some point and put it in the same directory. Go ahead. Well, dot means it's an object, and I'm calling it's an instance of an object, and I'm calling something on it. Objects are pointers. This guy was built when I built my dungeon out here. I built him using the new keyword that has pointer written all over it. So whenever we create instances of objects, it's going to be a memory address, which is a pointer. Okay. So now we've invented room. All right. So we're going to sit here and we're going to experiment with room for a few minutes. So well, here, I'll just comment it out. We're going to forget about our dungeon for a moment. But what I've done, at least right now, is I've invented a starting point for what a room is. A room has a name. We have a way of building an initial room. That means that creating an array of rooms is legal over here, and creating a room that is our starting point is also legal over here. All right. Notice this is along the lines of your question. We didn't have to say this is a room pointer. Objects hold memory addresses. Java knows this is a pointer. We don't have that special syntax where we have to say room star after it's saying this is going to be a pointer to a room. It's a variable of type room. Java will figure out that that's a memory address that points somewhere in memory where that room actually lives. Okay. But now I can get this whole thing to compile because I've invented room, which Dungeon uses. So if I go ahead and run this right now, it's not going to have any output because all programs begin and end with main, but at least it's not showing me any errors. All the stuff that needed to be invented was invented. All right, let's go ahead and create a room. So we'll say room R is equal to new room, and we'll say S118B, this room right here. And actually, just for a starting point, why don't we call this guy R1, call this guy R2. This is a new room, and we'll call this guy S120. That's the room down the hall. All right, so I have two separate rooms here. All right, now, because inside room, when I created this field, I didn't put any security measures in front of it. I didn't say public, private, or protected, whatever those mean. Okay. And I mentioned earlier in class that these guys by default have something called protected security. I'm sorry, package level security, which means anything that's in the same directory has access to them. Anything that's in the same package has direct access to them, which could be a directory inside of a directory as well. So what does that ultimately mean? What are the consequences of that fact? Well, if I want to print out the name of my first room, I can just say system.out.println r1.name. That seems pretty convenient. System.out.println r2.name. Seems pretty convenient. I'll get my S118B and my S120. All right. Now, so we might say, okay, well, I don't see a problem yet. Well, let's say somebody else is coming along and messing with your code. I mean, part of this is just kind of making sure you build in the right safety measures, even if they rarely need to get used. You're kind of making sure people use the class the way you intended for them to use the class. And what I mean by that is right now, because anything inside of the package, inside the current directory, can directly access this package level variable, I can just change its name. I can from outside say r1.name is equal to LOL. And now if I print out the name of if I print out R1's name after that, I see that it's now changed. So somebody externally has the ability to modify internal fields of that variable, which is not my intent. When I first create a room, the intent is that the name's kind of locked in. And if there's going to be any changes to that room, it should have to go through some sort of committee, right? Maybe a set name method inside of room that makes sure you're naming the room, without using colorful language or something like that. There should be some sort of oversight, right? So typically what we would do is we would make fields, at least as a starting point, private. Now, just making that one little change, just adding private there, now breaks main. Because this is no longer allowed. We're going to see, we're going to get an error. Say, name has private access in room. So let's talk about what private means. Security keywords, public, private, protected. Protected, we're going to kind of leave a little wishy-washy for right now. Public means anyone can access it. Private means only accessible from within the class itself. So since I made this guy private, I am allowed to access him like this. I'm still inside the class called room. He's a private field inside of a class called room, so I can access that guy from anywhere inside the class called room. Okay, now it's very important. This at some point I'll give you an example of this, but it's important that you listen to what I exactly said. You can access private fields in room anywhere inside the class called room, which means even if you have different instances of room, they could access each other's private fields because you are inside of the class called room. That might be a thing that you never even bump into, but it's still a thing. All right. So effectively what I'm doing here by making this guy private, and I would usually make the argument that start all your fields off as private and then loosen the grip a little bit if you need to. Okay. Is I'm saying, look, the name of this room gets set initially in the constructor. Some external entity can pass me the name they'd like this room to be, and I'll go ahead and set it for them on their behalf. But after this, nobody can externally modify that private field. Everything has to go through something inside the classroom. All right, that makes sense? All right, so that means that I can no longer do this. It's going to scream at me and say, hey, this guy has private access. You want to make a change? Take it up with room. Unfortunately, I haven't written the ability to make a change to this inside of room yet. I can come in room and I can create maybe a public method that returns nothing. And maybe I call this guy set name. Okay, I call this set name, and you can pass in a name and he'll go ahead and he is allowed, since this is inside of room, he's allowed to go ahead and change the name. Realistically, if I was only going to do this, I might as well make it public externally because I'm not doing any checking. I'm not making sure that it's not the empty string or something like that. I'm just like, hey, give me a name, I'll set it. No problem. Okay. But since this guy is public, I have access to him anywhere. If I left public off, that's fine. I still have access to him inside the directory. And I'm passing him a variable here. He does have access to this private field because we are inside the class called room. That makes sense? Go ahead.
So wouldn't you static as private?
Well, we didn't use static here because I want to be able to do things like this. Just copy this line. I want to be able to set individual rooms names equal to different values. So R1 has its own set name method, which controls the name of R1. R2 has its own set name method, which controls the name of R2. And that is why this guy does not have static out in front, because we wanted to exist one time for every single instance of this guy. All right, Go ahead.
It was static.
well, it would give us an error right now because it wouldn't know which name we're trying to set. We're not in a static context here with this. Now, this keyword wouldn't exist. All right, so for homework, finish prototyping all of the classes described in our notes, and I'll include it in the Blackboard assignment so that we have a starting point for creating our dungeon. All right, so you're only going to be able to implement a little bit of each thing. So you're going to kind of do something pretty similar to what we've done here. I'll go ahead and save this and I'll include this link. Okay, so you're kind of writing just the little beginning parts of each of our objects, just so they're ready to be expanded on.
Basically,
I want you to create exit. I want you to create no, they're only the things that make sense right now. So really the bare minimum, whatever's reasonable. So you're going to create, we've already done dungeon and room. You're going to create exit. You're going to create player. You're going to create monster. Go ahead and create inhabitant, but we're going to make some modifications to what that guy is as well. All right. Questions, comments, concerns, bribes. I did save it. All right. I'll see everybody on Monday.
Make the classes not instant.